Hello. It's May 1st, 2015, and this is episode 5 of the Unseen Podcast. The Unseen Podcast is the unscripted, unrehearsed, unedited spin-off of the Wow Signal. To learn more about the Wow Signal podcast, go to wowsignalpodcast.com. To learn more about this podcast, go to unseenpodcast.com. And if you're interested in joining the panel, this is an open participation podcast. Anyone who's interested can join the panel. Give me an email at unseenpodcast@gmail.com, and I'll tell you how you can be signed up. Tonight we have a new panelist, and that's something that I've been trying to make sure that we continually have new panelists on the show. But this is somebody you may be familiar with if you listen to the Wow Signal. His name is James Garrison. Say hello, James.
Hello, James.
Now, who is James Garrison? James Garrison.
Okay. James Garrison is the founder and head of the Oklahoma Skeptic Society. I am an occasional contributor to the Wow Signal podcast. I am a father, a farmer, wildlife, animal management, jack of all trades, basically.
Okay, thanks, James, and welcome to the Unseen panel. Hopefully you'll come back from time to time. And we also have with us a couple of people that have been on before. Ciro Villa.
Hello, Paul. How are you tonight?
Good. And Nick Nielsen.
Hello, Paul. Thanks for the invitation again.
Oh, well, you guys have earned extra points by showing up on short notice, so you get to appear more frequently. And also another way that people get to appear more frequently is by engaging in the Google Plus community, which both of you guys have done. So let's talk about tonight's topic, and I'm going to start by reading something. Now, I say this is an unscripted podcast, but here we're going to take a slight exception. I'm going to read something somebody else wrote. It'll be brief. This is the abstract to a paper that's been in the news a lot lately. Now, the headline you'll see is usually something like "No sign of advanced civilizations in 100,000 galaxies" or something like that. Or in one case, I think the Daily Mail, wrote something like 5 galaxies show signs of alien life or something like that, because that's a much sexier spin on this. Well, okay. This was actually, I think, in my opinion, a very interesting scientific paper. I know some of the panel have quibbles with it, and that's fine. That's the normal process. Let's talk about. I'm going to read you the abstract, and the paper is called "The GHAT Infrared Search for Extraterrestrial Civilizations with Large Energy Supplies 3." This is the third paper in a series, by the way. The reddest extended sources in WISE. And I should tell you that WISE is an infrared telescope that flew. Actually, it's still up there, but it's running out of coolant, so it's no longer that effective in the longer wave infrared. But it's called the WISE. I think it's WISE stands for Wide Field Infrared Survey Explorer. So that's what they're referring to with WISE. So I'll read you the abstract. It's by the authors are Roger L. Griffith, Jason T. Wright, Jessica Maldonado, Matthew S. Povich, Stein Sigurdsson, and Brendan Mullen. And the draft was received April 16th, 2015. Abstract. Nearby Type 3 galaxy spanning Kardashev super civilizations, and I'm sure we'll have a lot more to say about what a Kardashev super civilization is, would have high mid-infrared MIR luminosities We have used the Wide Field Infrared Survey Explorer, WISE, to survey approximately 1 times 10 to the 5th galaxies for extreme MIR emission, 10 to the 3rd times more galaxies than the only previous such search. We have calibrated the WISE All-Stars catalog pipeline products to improve its photometry for extended sources. We present 563 extended sources with B greater than or equal to 10, and B is galactic latitude in astronomy speak. It means outside the galactic plane. And red MIR colors, having visually vetted them to remove artifacts. No galaxies in our sample host an alien civilization reprocessing more than 85% of its starlight into the MIR, and only 50 galaxies, including ARP 220, have MIR luminosities consistent with greater than 50% reprocessing. 90 of these likely extragalactic sources have little literature presence. In most cases, they are likely barely resolved galaxies or pairs of galaxies undergoing large amounts of star formation. 5 are new to science and deserve further study. The BE star 48 Librae sits within an MIR nebula, and we suggest that it may be creating dust. WISE, 2MASS, and Spitzer imagery shows that the IRAS 04287 plus 6444 is consistent with a previously unnoticed, heavily extinguished cluster of young stellar objects. We identify 5 passive, i.e. red, spiral galaxies with unusually high MIR and low NUV. NUV stands for near ultraviolet luminosity. We search a set of optically dark H1 galaxies for MIR emission and find none. These 90 poorly understood sources and 5 anomalous passive spirals deserve follow-up via both SETI and conventional astrophysics. Okay, that's a little more nuanced than the headline.
Yeah,
they're not.
slightly.
They haven't found alien civilizations. They haven't not found them. They've just found they just have reached certain conclusions about certain classes of civilization. So who wants to go first in terms of what you think about this paper and the press reaction to it?
Well, I'd like to mention just off the top that while this is the paper that has gotten a lot of press, as you've mentioned, has been mentioned in newspapers, magazines, and a lot of blog posts, it is the third of 3 papers, and it is the paper that announces the result of their analysis of the WISE data, but it is preceded by 2 other papers, the Ultra-Red Search for Extraterrestrial Civilization, number 1, Background and Justification, and the second paper is number 2, Framework Strategy and First Result. And I think it is, although the results for obvious reasons are getting play in the press, you really can't understand the results unless you've gone through the other 2 papers to understand the theoretical framework of what they're doing, and then the actual the formalism they set up, which they call the agent formalism, how they're going to parameterize alien super civilizations. And this is interesting stuff, and there are, they've done something really interesting, and there are alternative formulations that could be pursued, but of course that gets more technical and doesn't make it into the headlines.
When they talk about a Kardashev civilization, I know, Nick, you've written about this before. Can let's tell our audience sort of from 30,000 feet, what do they mean by a Kardashev super civilization?
Well, Kardashev, of course, in a famous paper from 1964, introduced what he called types of super civilizations, or types of civilizations: type 1, type 2, type 3. And the type 1 is a smaller civilization of the sort of thing that we would recognize. Type 2 is much larger, and type 3 is galaxy spanning. And this has gotten a lot of people have taken Kardashevs and emissions and done all kinds of things with it. Most famously, Carl Sagan reformulated it in the first paper of these 3 papers on the survey. They describe in their first paper how they have used various reformulations of the original Kardashev idea. But I think one of the most interesting things to take away from the original Kardashev 1964 paper was his point, which isn't necessarily made explicit and has gotten lost in recent years, is that a very large, very old civilization would be capable of radiating astronomical radio source. And we know that there are very large, very powerful astronomical radio sources that can, there's one called 2C 395 or 3C 395, something like that, that's 5 billion light years distant. So we know we can get radio signals over very long distance. And if there were an extremely powerful civilization, the energy and emitting radio waves, we would know about it because it would be as bright as a radio galaxy.
Yeah, one of my understanding of the Kardashev scale is that one of the main parameters that the Kardashev scale is based on is the ability of a civilization to be able to harvest energy at different scale, correct? So basically, a type 1 only goes as far as its own planetary resources. Type 2 goes all the way to its star to be able to harvest energy at the level of its own star. And then when we're talking about a type 3, we actually be able to harvest the energy at the galactic scale. So that with that premise, one of the ideas I believe was of the research was to be able to see what the output or if you want to residue of such energy harvesting would be, and they, I guess the premise was that they would be visible at this kind of at this kind of spectral band, I suppose. Correct?
Well,
yeah.
I mean, it's just the waste heat, right? I mean, the laws of physics say you can't harvest a whole bunch of energy without giving off a lot of infrared.
Exactly.
Now they have to make assumptions about what temperature that infrared is, that waste heat is at. They don't have to make a specific assumption, but it's a broad assumption that it's, and they also have to assume that that the waste heat is kind of given off isotropically, that there's not that they can't somehow control the direction of it. But another thing that in addition to the waste heat, that's interesting, and I think you'll find in Jason Wright's blog post, is that a very advanced civilization could perhaps suppress supernovas, the formation of very small, very large young stars that blow up, and that that. So if in a galaxy like that, you would expect to see very few blue stars. You'd see a lot of red stars and maybe some yellow and green stars, but you wouldn't see the kind of stars that blow up catastrophically. And that's one of the things that they're looking for in these anomalous red spirals that they think deserve further attention.
So is the idea of that you would want to suppress supernovas because they would be damaging or they'd be potentially the source of gamma ray bursts?
Well, yeah, they could, if you filled up a galaxy with your intricate machines, you don't want supernovas going off.
Well, they could also possibly harvest the energy from a supernova if they're at a galactic level.
Well, that's a good point, James. I've never thought of that. I don't know how I don't know how any of this stuff would work. But
I'm thinking Doctor Who in the heart of the TARDIS. Honestly, he's got a supernova in the middle of it.
Oh.
So, but no question I have on this though is that if a galaxy has the technology and the knowledge to be a civilization and to basically harness all of the energy in that region, what would stop them from also having the technology to be able to mask any sort of radio signals or heat signatures or anything like that?
Physics and thermodynamics, presumably.
Yeah, we don't know how they could do it. I mean,
but that doesn't mean it's impossible. But from our current understanding of thermodynamics, as you said earlier, if you go through a lot of energy, there's going to be some waste heat as a result.
Yeah, there has to be some waste heat.
I think that there's a lot of anthropomorphic speculation also here that we have to take into consideration. I mean, true to be told, there's universal laws of physics that that we have observed and they've been studied, right? But at the same time, we also have to keep, I believe, an open enough mind to think that in a very advanced civilization might have been able at this point to go ahead and discover new forces or things that we do not even know about at this point. And they might have consequently been able to find ways to perhaps hide their energy, residue, or some other more exotic ways of harnessing the energy in the first place.
I completely agree with that, and we that there are things we don't know about. And in one of Kardashev's later papers, he considers that in some details and talk extremely advanced civilizations might well be are probably routinely harnessing technologies and sciences that we don't know about, and that has to be taken into consideration.
Yeah, the root of this is the Dyson sphere or the Dyson swarm, where it's a pretty simple model where you surround a star with some kind of starlight energy conversion technology, and that sphere would necessarily produce waste heat. But that's probably a very naive model.
Well, I think it's really exotic to have this idea of finding a Dyson sphere, but it distracts us from the overall point of view of trying to figure out what the thermodynamic profile of an advanced civilization would be, and that in turn needs to be seen in the larger context of what we're doing as we're trying to figure out what the detection signatures would be of an alien civilization. And so the example of a Dyson sphere, like I said, it's an exotic thing. It's fun to think about, but that's only one of many, many different possibilities, and we have to consider many different thermodynamic profiles. We have to think of many different detection signatures that we might be able to use to detect an alien civilization from an astronomical distance.
Right, Go ahead.
I was going to say, could also be that, as I believe as Ciro said, we're anthropomorphizing them. Who's to say that they have the same sorts of energy requirements that we have? If they're advanced enough, they may have found a way to harness, say, dark energy, dark matter, something like that, and are able to use that for a power source.
Right. And my point is that going back to the original, going back to the paper that that is the premise of this conversation. Obviously, these are scientists, and scientists have to base themselves on known theories and known physical laws that there are known here on Earth, right? They cannot be overly speculative.
That's right.
And so
no supposition with what they don't know.
Exactly. But at the same time, we also have to, if we want to really think about outside of the box, which is what we can do here, right? We have the freedom to do that, and we can think that an advanced civilization might have been able to, why not, discover laws of physics that we have not yet discovered, right?
Sure.
I mean, it's not fair. It's not unfair to think that far. Is it speculative? Of course, it's speculative. We don't know what we don't know. We know what we know. But at the same time, it's not too far-fetched to think that there might be forces out there. I mean, we are barely scratching the surface these days with the nature of dark matter, of dark energy. Actually, we don't even know what the real nature is of these two entities, right? So what's to say that we might be able to 10, maybe not 10, but 50, 100, 500 years from now, be able to progress, make so much scientific progress, And what is 100, 200 years, 500 years even? What is it in the overall scheme of the age of the universe? It's nothing, right?
Right.
So I don't know. I think that it's interesting to think that that there might be ways for an advanced civilization to completely shield themselves from the ability of other civilization, maybe less advanced, to be able to detect them. Period. Right.
Right. I mean, but I agree with you, Ciro, that scientists, the only way they can proceed is based on what they know, and so they can form hypotheses and test them. And everybody has to be a little humble and admit, yeah, we don't really know what an advanced civilization would do or why they would do it, but we can sort of look. But we're projecting from our own experience. We say, well, as life expands, it needs more energy. It's all about harvesting free energy out of the environment. If you don't harvest free energy out of the environment, then natural selection will take care of you, and those that do will prosper and
right. Well, we know it works.
Yeah,
we know how the universe works based on our understanding of how the universe works, right?
Right.
Not, in other words, that we don't know. Again, we don't know what we don't know. You know, I keep on saying, which may be that there's things out there that we haven't yet discovered. There's forces we haven't yet discovered. There's energies, why not, that we haven't yet discovered.
Right, but since we don't know what they are, we don't know how to form hypotheses about them. All right.
Oh, absolutely. Absolutely. I totally agree with that.
We do, in fact, our scientific hypotheses that we attempt to test have to come out of somewhere. They don't come out of nowhere, and they come out of ideas in which we try to reason about the unknown. Science tries to reason about the known, but before you can begin that process, you have to attempt to reason about the unknown. And of course, we do so poorly, and we make a lot of mistakes, but it has to come out of somewhere.
Oh, absolutely. I completely agree with that. And I don't mean to imply that, we can fantasize and go, and again, we can think about a million different things and without any kind of scientific basis or foundation. So I do completely understand that the premise of the authors, of the paper authors, they have to base themselves on the commonly and on what we understand nowadays of how physics work.
Yeah. Also,
that's
these
all
guys
we can do, right?
Right. Also, these guys probably have just about zero money. So all they can do is say, well, we have an existing WISE data set, right?
Yeah.
That was already paid for other purposes, and this is how SETI always works, right?
Right.
It's piggybacked on
science that can get funded.
On science that get funded. I talked to Jeff Marcy about a year ago, and he was doing optical SETI out at the Keck Observatory, and I asked him, how did you ever get the Keck Observatory to approve that? And he said, well, I just didn't tell them. I was hunting for exoplanets, and that's all they knew of. I didn't tell them I was looking for laser pulses at the same time. And if you're a rock star planet hunter like Jeff Marcy, you can do that. Now,
so is this basically a meta study?
No. Well, it was a study of an existing data set, but it wasn't a meta-analysis. No.
Okay.
It was an attempt to sort of data mine the existing set, and they did an enormous amount of work. Visually checking lots and lots of different sources to try to rule out known glitches in the way the WISE telescope performs. And there are a lot of little nuanced things that if you don't know about how that telescope behaves, you would think they were real, and they're not. They're just artifacts. So they mine the WISE survey, which is what a lot of astronomers do. They'll mine a survey for what they're looking for statistically, and they started out with 100,000 sources, but they ended up with a lot fewer when they were done. And that's something that kind of that the press has kind of missed. They thought that they had equally good data on these 100,000 sources, and they studied every one of the 100,000 sources to see if it could be a level 3 civilization, and that's not really what happened. They narrowed it down and narrowed it down and narrowed it down, and couldn't find anybody. They couldn't find any source that was clearly using more than 85% of the galaxy's energy, which is an enormously high percentage. of
Right.
and converting that to waste heat.
They couldn't find a smoking gun, but that doesn't mean that there's nothing out there.
Yeah, I mean, the WISE data set is the best we have, but it's still not that good. I mean, it's when you get the James Webb Telescope out there, you'll be able to use the WISE data set and also the his name's escaping me. There's another telescope out there to narrow down the targets for James Webb Space Telescope. And then it will be able to exquisitely characterize most of those sources, much better than we can do with WISE. WISE is basically little blobs of infrared light. But James Webb can turn those into, enormously detailed pictures. So it's going to be, assuming that it gets up there and is healthy on schedule, that in about 3 or 4 years, that's when you're going to see you could see a real revolution in our understanding of these galaxies. And so what they're trying to do is narrow down to the ones that need further study. I don't think they weren't hoping to find a smoking gun. They were hoping to find, these are a little unusual. They're not explained.
Yeah, that's absolutely true. And they've recommended further study of particularly interesting objects.
Exactly.
Yeah.
So basically, they're just calling out the least likely suspect.
Well, I think it's fair to say that of the objects they studied, they didn't find any with a massive signal that says, wow, somebody's using all the energy in that galaxy for waste heat. Mm-hmm. 100,000 galaxies is not a very high percentage of the known galaxies, but it's still, it's a lot of galaxies. And you would expect if this was a common phenomenon,
exactly,
you would have found one.
Exactly. You can extrapolate in a way and say, hey, if our galaxies have not shown any signs of this sort of emission, we can extrapolate that it's probably not going to be from another set of 100,000 galaxies. But again, it's all statistical, right? Obviously.
It's the way Kepler works, right? I mean, we look at this tiny patch of the sky, and we say, here's the planets they found in this little tiny patch of the sky that are within some fairly bounded distance from the Earth. It's certainly not a complete survey of all planets, but it gives us a sense of the statistics of planets.
Exactly.
In fact, the narrowness of the Kepler search is one of the interesting things about it. And we have to, if we're going to, we recur to the well-known cosmological principle to extrapolate that if this portion of the sky is like this, that other portions of the sky are like that, just like the Hubble ultra-deep field, which is a tiny little slice of the sky where supposedly nothing was, before it was focused on. And you find this huge number of galaxies, and you extrapolate that because of isotropy and the cosmological principle that's what the whole universe is like, mostly, with some exception.
Yeah, that's a great point. As a matter of fact, this is applicable in a lot of other studies, like you said, Nick. And this is why also, as you were alluding to, lately, I think the Drake equation can be easily revised because of the sheer number of exoplanetary bodies that we've been able to find in the last 5 or 6 years. We can
get real values for a lot of the elements, the terms of the Drake equation. But the Drake equation, like the Kardashev civilization types, other people have taken them up and massaged them and changed them and given alternative, which is great. And we need that kind of creative thinking to break out of the anthropic prejudice, as you mentioned earlier.
Right.
But what that entails is that you have to be clear about what you're talking about when you're talking about it, because different people say, one person says Kardashev type one, and similar with Drake equation, you have to make sure you're talking about when you're talking.
So there's some. So you're saying that some of the definitions are not necessarily universally agreed upon, right?
Yes, that's exactly what I'm saying.
Yeah.
And the Drake equation is more carefully quantified, but there's still the later elements that some people call the cultural terms of the definition of the equation are much more open to interpretation.
Right. Well, I mean, the Drake equation is a sledgehammer, not a scalpel. I mean, it's meant to sort of outline the research program, not to it's not the same thing as like a Lagrangian in the standard model. It's not meant to be calculated to many digits of precision. If you know it to an order of magnitude, you're doing better than most.
Right. It's about orders of magnitude, and that's what Kardashev was after. It's types of civilization too. It's about orders of magnitude.
But
it's a sledgehammer.
When I first heard the Drake equation, we only knew the first term reasonably well, and that's just sort of a rough average. Now we know the second term quite well, and the third term we have a pretty decent estimate of, and we're working hard on the fourth term. So I can see historically we're pushing across that equation. We're a long way from the fifth, sixth, and seventh terms, but I
agree. We are pushing our way through the equation, and once we get out and explore our solar system, and we can test for life in the oceans of the outer moons of the other planets, like we talked about in an earlier Unseen podcast, we can exponentially increase our knowledge of astrobiology. And then once beyond that, if we can fly in starships to other stars, we can exponentially increase our knowledge of the possibility of other civilization.
Well, I think all we really need is just some really big telescopes. We could possibly, much bigger than anything that's currently on the drawing boards, but we could get to where we could image and get the spectra of atmospheres.
Then that's why we're after detection signatures. Yeah. And one detection signature is the thermodynamic profile of a civilization.
Right.
Now, I do have a question real quick. If I remember right, the Fermi paradox, one of the factors one of the things he mentioned was that a civilization may get to the point where it wipes itself out before achieving basically one of Kardashev's super civilization statuses.
That's one of the arguments. That's one of the arguments, Paul, correct me if I'm wrong. That's one of the arguments for one of the possible reasons why we haven't detected extraterrestrial civilization. I'm sure Paul can explain this much more than I can.
That's a commonly offered, probably the most commonly offered solution to the Fermi paradox, that nobody gets past the great filter. And the great filter could be the discovery of nuclear weapons. It could be learning to burn all the CO2 in the ground that you have and overheating your planet. But I think that's probably not it. But it looks like we might actually get past the nuclear weapon thing with a little more luck. We're not there yet, but I think we've gotten past the worst of it. And so maybe that's not a great filter either. Maybe the great filter is simply the huge distances between stars, and nobody really develops the economic push to get to do that. But you just need, in the Fermi paradox, you just need one civilization that makes it through all those and has some kind of program that it can autonomously continue colonizing as it goes. And that's something that has been the subject of a lot of analysis. It turns out it depends on what you assume, right? If you assume that it's easy to colonize and it just takes time, we should be a colony.
Right.
And some people,
and there are those who believe we are.
Yes, and those are to believe we are.
Right, exactly.
There's although I can't point to any scientific evidence of that. Maybe there wouldn't be any, but and then there's to me the Fermi paradox is incredibly valuable, but it's not valuable because we know we can come up with an answer. We don't have an answer.
Well, it's valuable because we have many answers, and each answer suggests a research program.
That's right.
There's a wonderful book by Stephen Webb with the title something like
"Where's Everybody?" Yeah.
If the galaxy is teeming with aliens, where is everybody? In which he offers 50 different answers to the Fermi paradox.
Right.
And of course, you could add another 10 or 20 since that book was published. So there are a lot of potential answers, and each of those answers suggests a way to a different approach to the Fermi paradox.
Right. I think we have to be humble and recognize we don't know. But as Nick pointed out, if we ask the right questions, not so much what the answers are, it's what questions do those answers raise that we can actually answer, and or at least form hypotheses around and go look. And that's what the SETI people are doing. They've formed a hypothesis around something, which is a pretty naive set of assumptions, but it's a set of assumptions that are testable. And that's where you have to go. And you may not, it may take generations before you hit the right chord.
But even the negative results of SETI are interesting to me. I think it's absolutely fascinating, and many people have commented on the reluctance of SETI scientists to publish negative results, and that's one of the interesting things about the GHAT survey is they are publishing a negative result. But these are really important because it allows us to rule out certain classes of answers.
I completely agree with Nick. This is science is also a process of elimination. It's not just a process of discovery. I mean, a discovery comes out of also eliminating things, right?
Right.
You have hypotheses and you try to prove them or disprove them, and that disproving of certain things is as important as the proving of some other things.
Oh, I agree.
Yeah, it doesn't get you published,
right? And James is right, and it doesn't get you grant money. I mean, let's face it. A whole lot of science is built around grant money and publication and kudos for.
It is. It's driven that way.
Well, that's another reason why I think that a lot of these scientists have to be particularly careful when they formulate this, this scientific work, and when they publish this scientific work, because we can afford, right, to speculate and go right outside the boundaries with our minds, which there's nothing wrong with it. And I'm sure that a lot of these scientists are smart enough that they can think about, but they also constrained by their scientific and what they know. They cannot necessarily go too much into the speculative.
Well, they're also constrained by the socioeconomic context of their research, and
right, right, exactly.
They're walking on eggshells. I mean, everybody knows that when you write a grant proposal or a research proposal, all the things you can't say, and it really narrows down to the few things that are acceptable to say.
Right.
unless you happen to be Michio Kaku.
Yes, but he gets his money from book sales and not from, from appearances.
And he's a theorist. All he needs is pencil and paper. He's a theorist, right? And a few airplane tickets to go to conferences. So the people who want to,
regularly.
I spoke recently to Andrew Simeon, who's working on SETI on the square kilometer array. Now, the square kilometer array is a huge multinational investment in radio astronomy, and it's they have very cleverly, I think, worked SETI into the program, but they've been had to be pretty brave about it. They had to go in and say, we want to do SETI. We will do what they call commensal SETI, which is while you're observing a galaxy or a star, we'll turn on our receivers. And the nice thing about the square kilometer array, they can move the beams around a little bit. So you can have one beam that's looking at a distant galaxy and another beam that's looking at a star. And so they will be able to do that. But they had to be quite bold about that. And of course, the square kilometer array powers that be don't want anybody to think that this is primarily a SETI instrument. They're doing serious astronomy, damn it. And but they have come forward quite openly and said, this is what we want to do. And here's what we think we can find. And it's a very sensitive radio telescope. So that's kind of, it is difficult, but if you're like the UC Berkeley folks and willing to take that kind of chance, you can do it. And, young guys like Simeon, he's a SETI scientist. That's what he does, and, or you have very senior people like Jill Tarter, who said, look, I'm a SETI scientist. That's what I do. But, she's not risking anybody's grant money by doing that. In fact, she's going around getting money for SETI. So is there anything else that anybody wants to say about this particular GHAT paper right now? Or shall we talk about...
The only thing I wanted to do it, Paul, it was that there was some leftover pending question marks that I think that have been a little bit misconstrued by some of the media, or purposely, maybe some of them purposely by some of the media, where they were claiming, that I've read at least one source claiming that 50 of the galaxies had. They went as far as saying that 50 of the galaxies might have extraterrestrial civilization, which we know that's not what the paper says at all.
No.
But, I guess they kind of, there is something left over, right, in the paper saying that there are certain sources that are, subject of, recommended to be subject of further study.
Right.
And the people who are really interested will take the trouble to read the paper, and they will be a self-selected minority of those who are willing to go beyond the headline.
Yeah, well, the paper is very technical in places.
Certainly.
It goes into a lot of, if you don't know what a micron is, you're lost right away. So right. I think it's actually quite well done, but and my background in infrared astronomy is not very strong, so I had to struggle a bit, but that's podcasts like this and other people sort of we're supposed to be the sort of the middlemen who understand it well enough to make sure that it doesn't get overinterpreted or underinterpreted. Right. But now there are some good science journalists out there who will dig in. But and good science communicators, but there are like Brian Koberline's a very good example. He's been talking about these topics lately.
Brian Koberline.
Yeah, he's got a new podcast called One Universe at a Time. Very good. But
blog post yesterday.
Yeah, but and Brian's an astrophysicist, so he understands these subjects pretty well. But we do have to, I think we do have to help push things along towards understanding that what the scientists are saying is careful and more nuanced than any headline. And there are a few good science journalists, but a lot of, I've dealt with stories before that were in the press that I've been working on personally. And some of the stories I see coming out, I don't recognize what it is they're talking about. And that's not the satellite I was working on, or what. They don't always get it right, and a lot of times they're very dependent on the press release, which is written by PR people and not by scientists. And so that's, we can hopefully perform a service if people are thinking, oh my God, there's no advanced civilizations out there. They looked and they didn't find any. Well, okay, that's not what they concluded. Nor did they conclude that they found any. So, the search goes on. And I think the GHAT people are doing good work. And I'm trying.
Hopefully they'll follow it up with further study.
Yeah.
And look at some of those interesting outliers.
Yeah, and I'm trying to get one of the co-authors on the WOW signal. We'll have a long talk. So the next topic for tonight is the chief scientist of NASA, Ellen Stofan, and her recent claim. It's in I'll have a link to the article in the Huffington Post. It says, NASA chief scientist Ellen Stofan predicts we'll find signs of alien life within 10 years. That's not exactly what she said, but she said maybe as soon as 10 years, but it could be longer. What she said, she says, I think in the next 20 years we will find out we are not alone in the universe. And so 10 years is pretty optimistic in my view, unless there's some low-hanging fruit we just haven't seen yet. And there could be.
Well, it really depends on what you mean, which is a topic of a couple different things I wrote for Centauri Dreams a while back. Would you feel less alone if you knew that there were stromatolites on a planet circling Tau Ceti? Well, maybe some people would, maybe some people won't. So it comes down to how close of an approximation to our civilization you have to have, which I call a pure civilization.
Yeah.
For someone to say, yes, I feel less alone. I know that there are stromatolites out there, and there's stromatolites here, so we have something in common.
Well, just the fact that they find microbes in a extraterrestrial location, even if it's one of the moon, Europa or something like that, kind of does give credence to the fact that there may be more intelligent life farther out in the universe.
Yeah. I think it does, especially if we find that it was a completely independent genesis.
Mm-hmm.
I think there's a philosophical there's a philosophical argument. I guess if you were looking at like what Nick was saying, would we feel less alone if we discover microbes or bacteria? Well, maybe we wouldn't feel less alone, but at the same time, the existence of life, just one of the other bodies in the solar system, would open up so much in terms of possibilities, right? Even statistically, I mean, even just discovering one body as the evidence of life on one body would signify so much.
Yeah, well, that would be an exponential increase in our knowledge of astrobiology. There's no question about that.
Exactly.
And I started skimming a Huffington Post article on the news item here about Ellen Stofan, and they specifically say, we are not talking about little green men, Stofan said. We are talking about little microbes.
Exactly.
So their criteria for not being alone in the universe are probably right. But whether other people would feel less alone to know that there are microbes on Titan or Europa, that's another question.
I don't know. I know some people that don't like them, so
yeah.
Well, I mean,
she says the evidence about in 10 years' time, she says, I think we're going to have strong indication. This is a quote, I think a quote from her. I think we're going to have strong indications of life beyond Earth within a decade. And I think we're going to have definitive evidence within 20 to 30 years. So this is what she says.
Yeah, I think that's not too optimistic. It's possible. I mean,
if we get a satellite flying through the plumes coming out of the oceans of Enceladus or Europa, yeah, we could do that within 20, 30 years.
Yeah, I think so. Or possibly understand that out of equilibrium chemistry in the atmosphere of Venus, which is.
There's another important point too, Paul, which is that she and no point she seems to indicate that we are going to necessarily find the evidence of current life, right? And my interpretation from just by the quote alone that I just read is that she's saying evidence of life, which means it could be life that has existed at some point in the past, right?
Oh yeah, like fossil microbes on Mars.
Well, I mean, I don't think enough attention's been paid to Noronofsky's hypothesis about microbial mats and the Curiosity images. I think she did very careful work there, and she was largely dismissed by not all the Curiosity team, but some of them. Say, oh, we looked at that, we didn't see anything important. But here's like a world-class expert in microbial mats, and she's studied them all over the Earth, and she looks at that and she goes, that looks familiar, and started to really dig in and analyze the images. Now, it's not proof that there are microbial mats there, but it certainly goes a long way to making you think that we should study that more. There may be already evidence right there on the surface of Mars that is telling us, there was 3 billion years ago, 4 billion years ago, microbes. Now,
which in my opinion would still be great. I mean, even discovering that life had existed even some 1 million or 2 million years ago would be a great discovery, in my opinion.
I agree.
It would. And as Paul mentioned in an earlier Unseen podcast, it will discover at that point whether the matter exchange between the inner planets it means it's all just one genesis or there's separate genesis of life. And in each stage, as we push our way out further into the solar system and then further out into the galaxy, we'll learn exponentially more about how related and interrelated life is.
Yeah, right. And it's entirely possible we would find past life on Mars, extant life in the atmosphere of Venus, and they would all be related to us. It's entirely possible.
Yes, it is entirely possible. That's what we're going to learn when we get to study those potential microbial mats. In
fact, it's almost certain that Earth microbes have made the trip to Mars a few times.
Well, we already know they've made the trip to there was this famous case of somebody who sneezed on an early NASA moon probe, and the Apollo astronauts brought back a part of that and found, even after its exposure to the vacuum of space and the radiation, that there were still live germs in the inside of one of those pieces they brought back.
Yeah, so
they repeated that with a rocket too.
In fact, there was some bacteria, I believe, that were found outside of the International Space Station, if I'm mistaken.
Yeah.
Unless I'm confusing with a different story.
No, I understand that. Remember that story. I'm not sure what the upshot of that was. If they were really there, or if it was some contamination or something. But although I don't think it's completely implausible.
No, we have to start taking seriously theories of life forming not merely on the surface of planets, but also in circumstellar clouds of dust and gas, or in comets, etc.
That's an excellent point that Nick has just made. As a matter of fact, it reminded me of some of the studies that have been done recently in Antarctica that have found how much more resilient some bacteria's life forms are than originally thought. I mean, they found bacteria thriving in environments that are almost unthinkable.
Okay, hard. They can survive vacuum of space. They can survive extreme heat, extreme cold, dehydration, or multicellular organism.
Right. So basically, this opens up so many more so many of environment, of exotic environments where some life, any kind of life, could be in existence, and we just have to find it. And some of these places are so inaccessible to us based on the technology that we have today that's the only reason why we haven't found them yet.
Yeah.
And I might point out that genetically engineered extremophiles could be an effective vector for terraforming Venus or Mars.
Yes. I think that I'm a little skeptical about Venus, but I mean even Venus is possible.
Well, Venus, I assume you're skeptical because it's so hot on the surface. But we could cool it down with what I can't remember the author's name of the study. There's a bunch of people who are researching what they call Dyson dots.
I'm familiar with that. Yeah,
which is a slight shade that you can erect between a planet and the sun that would cool it by a few degrees or more if you needed to. With reasonably accessible technology, we could cool down Venus, could warm up Mars, and
could there be extremophiles living under the surface of Venus? Is it possible? There's some extremophiles.
Hypothesized that, yes.
Yeah.
And there's even people who have suggested that on the poles of Mars there might be extremophiles living.
Yeah, interesting.
I said Mars. Excuse me. I meant Mercury. Mercury.
Oh, right. Yeah, there is water there. Yeah. So yeah, that's possible. We don't know.
That would be a tough organism.
Yes, it would. But our experience of life on Earth is that the organisms are tough, right? Very resilient.
Right, exactly. And that's the fact. I think that's the exciting thing, that it's only a matter of technological capabilities. Just because we don't have the technological capabilities yet to reach some of these places that we might not have found, the evidence of life forms. And there's so many. I mean, if we really think about, we've explored the solar system in only in the last 50, 60 years. I mean, scrape the surface of the places that we visit in the solar system alone.
Yeah. We have much to learn right here in our own backyard. That's absolutely true.
Mm-hmm. Exactly.
Yeah, about 50 years. And I think the last 30 years we've learned an enormous amount. Partly a lot from Galileo and Cassini and the Mars orbiters and rovers, and also the Venus probes that have, and well, of course, Messenger, which just crashed into Venus yesterday, into Mercury, sorry, with, greatly expanded our understanding of Mercury. So yeah, we've had that. Yeah, and also there's much better understanding of the sun. So, there's I think that's sort of the next frontier for planetary exploration is going to look for habitable environments. We think there might be one on Enceladus. I think there might be in Europa, other places too. Venus, atmosphere, maybe under the surface of Mars, maybe on Titan, where you'd see some very strange life indeed, but it could be there. Mm-hmm. So
it's likely that our civilization will be profoundly impacted by that amazing increase in scientific knowledge that's going to come from that, and we can see ourselves right on the verge of it.
Yeah, I think so. I think that it's just a question of having the will to do it. And hopefully, it doesn't need to necessarily be a United States that does it, but somebody should go there. Right. It might be the Chinese or the Japanese or the Indians or
news item yesterday that the Chinese.
Sorry, go ahead.
I was just going to say there was a news item yesterday about the Chinese and the Russians possibly getting together on a space station.
Yes. I don't know how much more we have to learn by orbiting around and around in low Earth orbit, but
well, if it's a jumping off point for further scientific missions, again, we could certainly learn more from better and larger telescopes in orbit. If you look at what we learned from the Hubble Space Telescope, just scale that up, and other than using telescopes other than in the visual range, there's still a lot to be learned.
Yeah, and I think that the telescopes are certainly a huge frontier there. I mean, there's already been a lot of discussion about the James Webb Space Telescope, which in the U.S. is generally called At Last, and there are people at Goddard who are studying that, and there are other, there's a lot of work done on other parts of the electromagnetic spectrum, which have continue to get better. And I hope that once we get to the square kilometer array, that will point us in new directions as well. In fact,
have they finished that, or are they still working on it?
It's really just still in development.
Okay.
They just announced this week, I think, that the headquarters will be at Jodrell Bank, although the telescope itself is going to be mostly built in Africa. So, South Africa.
I think that we are one big discovery away. I don't want to be over optimistic. One big discovery away from reigniting the entire space program, only in the United States but worldwide. And the reason why I'm saying that is because a lot of
I'm sorry.
Even the
Ciro, say that again. I think we lost you there for a bit. You said we're one big discovery away from.
Yeah, I think that we're one discovery away from, from reigniting. We're one big discovery away from reigniting the space program, not only in the United States but perhaps even worldwide.
Yeah.
Political decisions, even economic decisions that have been made historically have been emotions and the perception of the value of spending the money for something, right? So if we were, for example, to make one big discovery on during, let's say, for example, on Mars, I mean, I think that would be enough to, it has to be a significant discovery, no doubt about it. But one discovery would probably tell our entire system that, hey, it's important to continue space exploration. It is important to spend the money for space exploration.
But yeah, it's not just discoveries. I think you have to also look on the commercial side. There are going to be an endless number of firsts. And the first private company to plant its flag on the moon, and the first private company to plant its flag on human civilization lasts, and any successor civilization lasts, and that itself should be a big low-hanging plum for industry that wants its name remembered.
Well, my point is that the political system, the politicians are obviously influenced by the public, right? I mean, obviously, especially, particularly in democratic countries like the United States, politicians are influenced by what the public wants. And so I think that, if the public gets excited about space again, I mean, the politicians cannot not fund space more if it's asked, if it's demanded, right, by the public, I suppose.
But public money
bankroll it.
Public money dries up when the economy goes sour, whereas the concentration of wealth we're seeing means that there are a handful of people in the world with billions of dollars at their disposal, like Jeff Bezos funding Blue Origin.
Right.
Private industry is going to eventually take this over and go places where governments never went.
Yeah, I mean,
we just need to tell the Koch brothers that there's oil on Mars.
Well,
there is oil on Titan.
Yes, there is
a lot of gas.
Yeah,
a lot of gas.
A lot of natural gas on Titan. Yeah. Well, companies today like Apple have more really available cash than any government. Cash is sitting there, not unspoken for, and no debt. And Google is constantly putting money into blue sky type of things. And we don't need the huge program. We don't need something as big as, say, the Afghanistan war, which was that about $1 trillion. We don't need that. We just need something 2 orders of magnitude smaller, and we could do an enormous amount.
We just need reasonably priced delivery of cargo to low Earth orbit, which could be provided by any number of different projects that are on the drawing boards, and some are in the process of being manufactured now, like the Skylon space plane. That's a really hopeful sign to me.
Yeah.
I think at the end we go back to kind of in a circle to what I think Nick was mentioning at the beginning. I think that we go back to fundamental philosophical questions of what really is important for as humans to spend the money on, right? I mean, if the majority of us thinks that discovering little green man, it's not really as important as spending money on other things right here on Earth, then there are people not going to spend the money to search for little green man.
But a lot of it has to do with how it's actually presented to the public, because when it's when it's presented to people as little green men, it immediately becomes a laugh line. But if you actually talk to people, or especially if you talk to children and find what gets people excited and interested, you'll still find that a lot of kids want to be astronauts.
Right.
And find the idea of exploration. It's only when they get older and they get that all the excitement beat out of them, and they are forced to pay bills and get a job that they develop a more cynical perspective, and you have to get people while they're still young and enthusiastic and interested, and get them to really believe, well, there are things that you can do, and there are things that we don't have to accept business as usual and politics as usual. And we can do much more than we're doing now.
That's an excellent point, and I don't know. I'm sure that some people that have more expertise are doing studies of why that's the case. But there's the loss of the enthusiasm when kids reach a certain age for some reason. Not all of them, right? But a high percentage, unfortunately.
Well, it's also the evolution of our particular culture, or the culture of the industrialized countries has changed in unexpected ways.
Yeah, I went through that. I briefly, for a few years, kind of lost my enthusiasm. It had to do with a lot of different factors, but I came back to it. Because I kind of felt like, what's life about? What's it for? Oh, well, it's not about sitting. It's not about sitting on our butts waiting to retire. It's
well. Also, there's a mentality of instant gratification that I noticed a lot of people have. A lot of people do not really see many tangible. I mean, there's a lot of space. We're not talking about the space enthusiasts, right? The people like us, and we're talking about the average Joe out there. A lot of people criticize, and the line that you hear on a daily basis is, "Why are we spending money to go and why are we wasting money?" That's how they put it. Why are we wasting money to go out there and do these things that we do? It's because they don't see any value into doing that.
Well, I don't think they know how much money is involved, how it compares to, say, the cost of, 6 months of a war, or 6 weeks of a war, or
6 months of the presidential campaign, for that matter.
Yeah, it's or how it compares to, say, how much money is spent on a stadium, a football stadium.
Well, let alone the fact that a lot of the scientific discoveries that are made in space now, not only aboard of the international, as is well proven, but the ability that we could somehow find new energy sources, that we might find something new on another planet. Who's to say that the future generations are not going to be able to benefit from it? I mean, even thinking about how the resources are going to get depleted on our planet at some point in the future, we're going to need to find a new home, right?
Well, at some point, yeah, I think you can make the argument, which I accept, that we have to become a spacefaring civilization to survive in the long term. But that's a hard sell. It is.
It's a hard sell to someone who's having trouble making their bills, and getting somebody excited when they're completely consumed with the practical details of everyday life. It is the challenge, and there are ways to do it. It's just that there's very little will to do it.
Yeah, well, when I travel around the country and around the world, I see that there is tremendous human energy out there. People put their hearts and souls into all kinds of things, and it's just a question of how that energy gets channeled and why.
I absolutely agree with you, Paul. And there's a lot of revival also into the younger generation in the interest in space and science. Unfortunately, though, some of this, a lot of that is also misguided in many ways. I mean, there's a lot of people that are excited about it, but maybe not necessarily excited in the right ways. You know what I mean?
I can give you one possible example. I don't know what you mean, but the confusion in the public mind with various kinds of pseudoscience, and
that's what I mean. I mean,
it's the underbelly of industrial technological civilization. Because if you look at earlier civilization, where religion was the organizing principle, the underbelly of Christendom in Western Europe was the idea of Satanism. And today, the underbelly of scientific civilization is this anti-science and pseudoscience, and it's not going to go away. It's going to get worse. The more our society is shaped by science, the more anti-science is going to play a role in it, unfortunately.
Well, it's not always anti-science. A lot of times it's just the fact that a lot of people are illiterate. They don't understand the basics of science. I don't mean that. I'm not saying they're dumb. A lot of times they're very smart people, but they just don't understand that science isn't about explaining the truth, about finding a truth. They don't understand that science isn't about finding the truth.
Yeah, I think that's an excellent point that James is raising. That social media and the internet adds to that confusion by a lot, in my opinion.
Yeah, it puts a megaphone in the hands of idiots. Absolutely.
Well, I think
there's a lot of
yeah. I think there's some blame to be placed upon this new generation of science fans who love science, but really what they love are the pretty pictures, and they love
I've heard some people argue.
Yeah, go ahead.
I've heard some people arguing that any publicity is good publicity. I mean, even some scientists have argued that any publicity is good publicity. Because you can go to social media and see a lot of pretty pictures of a galaxy. Yeah, that's beautiful, right? But there's so much confusion. There's so much misinformation out there. That's mind-boggling, and it's troubling too. In many ways.
Part of it is they don't really know when they say they love science. What they mean is they love the results of science. They don't really love the hard work.
They love
and the vast amounts of money, and the blind alleys and the frustration and the burned out graduate students. They don't love that. They love the pictures. They love hearing about new species or new results. And that's that's not that's not really loving science. That's just loving facts about science.
Yes, somebody, and for the life of me I can't remember them, but a while back they said true science isn't when you find isn't when somebody says eureka. It's when you say, "Huh, that's interesting." So, and people don't understand that more science is done when you don't have an answer, when you don't prove something, than when you prove it.
Yeah.
But if you can harness that native curiosity that produces the that's interesting. And you don't even have to talk to people about science, but you can just say, you don't have to stop at You can look into this, you can investigate it, you can learn things about it.
Sure.
Yeah, which a lot of people in the scientific fields do, but when you're talking to the common man, like a lot of people I deal with on a daily basis, you can't, like you were saying earlier, people trying to pay bills, trying to make ends meet, they don't have that energy to put forward into digging deeper.
Mostly not, no. Well, maybe when robots free us all from work, then we'll have the bandwidth to deal with this kind of stuff.
Oh boy, I had a conversation about robots today. Oh boy.
Yeah, well, the automation of agriculture, I'm sure, is impacting the region where you live, and I understand a lot of combines are just guided by satellite technology, and you don't even have to have a person driving them anymore.
No, you actually do still have to have a person in there. The GPS systems are pretty effective, but sometimes you get a glitch in the satellite and the thing doesn't know to stop before it hits the sheep field.
Oh.
So
hopefully they'll work on the algorithms for that, and I suspect that the automated combines will be operational before automated cars are on the road in large numbers.
Probably. It's just around here you have the God created the farmer, need to have work type of mentality. They don't want robots, they don't want automation.
Right, and there will always be some kind of a market for boutique farming, but people who want to keep their hands in the soil, as it were, are going to have to move into high-end organic specialty things rather than producing enough corn to feed the world's feedlots.
Yeah.
Or like I do in wheat and cattle.
Yeah. Well,
I actually raise cattle and have wheat, so.
Yeah, well, around here in Maryland, nobody can make money from mass scale farming. So, but you see a lot of vineyards, and you see a lot of little, garden farms where
specialties,
roadside stores, that sort of thing, or farmers markets. Mm-hmm. And that's some good eating. That's I love to get my food from the farmers market. So, but it's 3 or 4 times what it costs you in the grocery store. So.
It's because they know you'll pay it.
Yeah, I will. Just tell me that it's grass fed or whatever, and I'll pay extra.
I can tell you all of our cattle are grass fed, but that's just because they're out in the pasture.
Yeah. Can we kind of how can we bring this full circle? We started talking about advanced civilizations. Now we're talking about some advances on our own civilization, which are not everybody's going to like. And that's how it always is, right? Sometimes advances result in hardship for the people that are in the past generation. Like when we went to agriculture 10,000 years ago, that was a harder life for those people than it had been as hunter-gatherers.
In fact, some anthropologists refer to the Paleolithic golden age that preceded it, because people were larger, they were healthier, they were longer lived, and the farmers that followed them were smaller in stature, and they lived shorter lives, and their teeth were all ground down by the crude methods they used to grind their flour.
Right, but they had more babies, and
they did.
And
they had more babies,
and that's why they're here, and the hunter-gatherers aren't, or not in large numbers.
Except for in no significant numbers, right?
And that's really basically how it works, right? I mean, it doesn't really matter what you intend, or what.
It's the unintended consequences.
Right, well, it's just that. No, I don't think anybody said, "Hey, let's have an agricultural revolution," right?
No. Civilization is not the result of planning or intention. Even industrialized civilization, it just happened to us.
Right.
If people would have stopped it if they had the chance, if they saw what we were getting ourselves into.
Well, and some people did try to, but I mean, and it was hard for the industrial workers of the first several generations. It was really hard.
It's still hard for many industrial workers.
It's not as bad as it used to be, but
you look into the conditions.
Yeah.
No, but if you look at the conditions of many people work in, and I don't just mean in the third world. If you look at the working class people in the United States, many people work very, very hard just to get enough to feed their family.
Well, I mean, my grandfather was a farmer born in the 19th century. He had never knew a day without, 6 days a week. It was brutally hard work. For the time he was very young. And that's just how it was for those people. And they that was their value. Anybody who didn't work hard was a worthless person who didn't deserve anything. So, and those folks, the agrarian people didn't like what they saw in the Industrial Revolution. And now we have people who are coal miners who've driven the Industrial Revolution for generations and generations. They're resisting the move to nuclear or other clean sources because, it takes away their jobs. So
they don't want to lose their job. Yeah. They've done the same job for 30 or 40 years, and they don't want to suddenly be left at age 50 or 60 with nothing to do.
Even though, if they have to admit it, they've had a hard life, but they it's their life.
Yeah.
And
it is.
So, and when the robot revolution comes, it's going to be a hard life for the first few people that are in there, the first few generations. But
the adjustment, the adjustment will be very difficult, just as many adjustments going on in our economy now are attended by a great deal of wailing and gnashing of teeth.
Right. Well, gentlemen, it's been fun. I think we had a great conversation. I think we're going to wrap it up here shortly. I'll go around the table. Anybody wants to make one last comment? James?
I've learned a lot. I felt like comedic relief, but it was a very interesting conversation, guys. I had a lot of fun.
Oh, comedic relief is extra points, by the way.
Good.
Ciro?
I'll bring my little flower and nose next.
Ciro, anything last words?
Yes, Paul. First of all, thank you so much for having me on the show again. And I don't know. I think that, I think this is exciting times. That's all I'm going to say. This is exciting times. I think that the future generation are probably going to look at us and laugh. Because they're probably going to be like, I cannot believe that they didn't see what we see today. It's kind of what we do. It's a course of history. We always take for granted what we have, and and it's hard to appreciate the legacy of how we got to this point. And it's going to be the same in the future.
Nick?
Like Ciro, I'd like to thank you for appearing again, and to add to what Ciro was saying, it is almost always the case that unintended consequences grow beyond the intended consequences and come to define. So, who knows what's next? But thanks for.
Yeah, well, I'd like to thank James Garrison, Ciro Villa, and Nick Nielsen for being our panel tonight. And I'd like to briefly talk about the future of the podcast. I'm so far encouraged with what we've done and have achieved this date. This is episode 5. I'm planning to take a major evaluation of where we are at episode 25, which will be about 6 months into the podcast. I have some goals in mind. The most important thing is actually the quality of the conversation that we're having. But that's difficult to measure. So I'm also going to be looking at things like how many different panelists did we have on, and tonight we had a new one, so that's good. I'll look at is our audience starting to grow. I'm not too concerned with our download statistics right now. They're not bad for a new podcast, but they could be a lot better. But we should start seeing some growth. And I would also like to see a lot more engagement with our audience. I want to know who you are listening to this podcast. And for that reason, I started a subreddit on Reddit, of course. And if you want to go there, if you're a Reddit type person, you can go there and comment, ask questions, and do whatever, say anything you like about the podcast and make any suggestions you want to. And if you have questions, we'll try to get them answered. If you have corrections to anything we said tonight, which is entirely possible, then by all means, let us know. And we thank you for listening. Another way you can help, but besides engaging, is we could really use some reviews on iTunes. If you want to support the show, right now I don't really have a way to financially support the show. But if you want to support the Wow Signal, you can go to wowsignalpodcast.com and click on support the show, and you can see how you can do that on Patreon. Right now, I have no plans to set up a separate Patreon account for this podcast, but that may happen at some point. So this has been episode 5 of the Unseen Podcast. To learn more, and including information about our panel, go to unseenpodcast.com. And we hope to see you 1 week from today. Good night, everybody.
Good night. Thank you much.
Good night.